Hey guys, we're going to go over today Sir Isaac Newton's laws of motion. This is classical mechanics, and there's 3 laws of motion that we're going to go over today. Newton's first law, objects in motion tend to stay in motion, and objects at rest tend to stay at rest unless acted upon by an unbalanced force. Newton's second law, force equals mass times acceleration, F equals m times a. We write it out, F equals ma. Ma is m times a. Newton's third law, for every action there is an equal and opposite reaction. What are Newton's laws of motion? Newton's laws of motion help us to understand how objects behave when they are standing still, when they are moving, and when forces act upon them. There are 3 laws of motion. Here is a description of Sir Isaac Newton's laws of motion and a summary of what they mean. Newton's first law of motion, okay, here we go. Newton's first law of motion states that an object in motion tends to stay in motion unless external forces act upon it. Similarly, if the object is at rest, it will remain at rest unless unbalanced force acts upon it. Newton's first law of motion is also known as the law of inertia. Law of inertia. Remember that. That's going to be on a test. Basically, what Newton's first law is saying is that objects behave predictably. Okay, we can predict what objects do. We can tell you what they're going to do in the future by calculations. If a ball is sitting on your table, it isn't going to start rolling off the table unless a force is acted upon it to cause it to do so. Balls don't just sit there and jump up and down all by themselves. Something is doing it. Moving objects don't change their direction unless a force causes them to move their path. So a ball needs a force to get moving. All right. Newton's first law, objects in motion tend to stay in motion unless objects at rest tend to stay at rest unless a force acts upon them. And the second law, we said force equals mass times acceleration. We write it out as F equals ma. Ma means m times a multiplied by a. Newton's third law, for every action there is an equal and opposite reaction. Here's Newton's law of motion. Force is a person pushing it. Mass is the weight of the object, and velocity, the acceleration, is where it's moving. Okay, as you know, if you slide a block across a table, it eventually stops rather than continuing on forever. This is because the frictional force opposes the continued movement. If you threw a ball out in space, there is much less resistance, so the ball would continue onward for a much greater time because there's zero gravity in space. There's gravity on Earth, which can be calculated. Different planets have different gravity. Mars has less gravity than Earth. Place like Jupiter or the Europa, the moon of Saturn or Jupiter, may have less gravity than Earth, so things are going to be different. Newton's second law of motion states that when a force acts on an object, it will cause the object to accelerate. The larger the mass of the object, the greater the force will need to be caused to accelerate. This law may be written as force equals mass multiplied by acceleration. Like we said, F equals m times a. It's a very important formula that you're going to be using a lot in classical physics. Okay, another way to state the second law is to say it takes more force to move a heavy object than it does to move a light object. So if something's lighter, it will easily be pushed up as opposed to something very heavy. The law also explains deceleration or slowing down. You can think of deceleration while moving backwards or slower as accelerating with a negative sign. So you're pushing, it's getting force pushing back against it. For example, a ball rolling down a hill moves faster or accelerates as gravity acts on it in the same direction as the motion. So as you're pushing a ball, gravity is pushing the ball back in a negative way. So it's negative. If the ball is rolled up the hill, the force or gravity acts upon it, and the deceleration of motion, acceleration is negative, or the ball decelerates. Newton's third law of motion states that for every action, there's an equal and opposite reaction. What this means is that pushing an object causes the object to push back against you on the same as the same amount, but the opposite direction. For example, when you're standing on the ground, you are pushing down on earth with the same magnitude or force that is pushing back up to you. History on Newton's law of motion. Sir Isaac Newton introduced the third laws of inertia in 1687. He published a book, and that can be used today. Let's go over what force is. Force is a push or pull. Force acts in a certain direction. There are many examples of force in nature: electrical force, magnetic force, gravitational force, and weight. What is mass? Mass is a measure of matter, inertia. Mass depends on the number of kind of atoms. The mass of an object is the mass of an object regardless of where it is. It can be used in kilograms. What is acceleration? Acceleration is the rate at which velocity changes over time. An object will accelerate if the speed, direction of motion, or both change.